All right, you all tried this, right? I know you did because you love math and you want to learn. Okay, so the first one, the endpoints. We've got two endpoints. We'll even do this, like this. Here's A, here's B. We're looking for the midpoint. So I take the average of my x's. So 1 plus 7 divided by 2. That gives me my x coordinate. And then I take the average of my y values. 2 plus 8 over 2. And that's going to give me 8 over 2, 10 over 2, which is 4 and 5. So M right here is 4, 5. Again, you can always stop this and go back if you need to see it. Okay, this one is a little trickier, like the one before. We've got an endpoint already, t, let's say this is 1, 1, and I have my midpoint, which is 2, 4, and I'm looking for this x and y value. So I know that my midpoint, which is 2, 4, equals the average of my x values, so I need to add those together and divide by 2, and then the average of my y values. So 1 plus y over 2. And now I've got my two separate equations again, and I'm going to come over here. So I've got 1 plus x divided by 2 equals 2 to get my x value, and I have 1 plus y over 2 equals 4. Multiply both sides by 2. That gets rid of that, so 1 plus x equals 4. So x is 3. Again, that sounds familiar. Multiply by 2 on both sides, so I have 1 plus y equals 8, and I subtract 1 from both sides, and I have y is 7. So my answer then, my x and y value is 3, 7. That's not the endpoint, I'm sorry, that's not the midpoint, it's the endpoint, given this information. All right, I hope you did that, I hope you got it right. Okay, so switching gears just a little tiny bit. What is the Pythagorean theorem? I think a lot of you know that already. You've probably covered it before. It's when we have a right triangle and we have a side A, a side B, and my hypotenuse C, and A squared plus B squared equals C squared. I could also write it C squared equals A squared plus B squared. And what does it measure? It measures the length of those sides. And that's kind of what we've been talking about, line segments and lengths of sides and things. So let's say I wanted to find C. Well, if I wanted to get C by itself here, I would need to take the square root of both sides. Don't worry about knowing this. I'm just showing you where the distance formula kind of comes from. Okay, so I'm left with C equals the square root of A squared plus B squared. Okay, so just kind of take a little snapshot of that in your head, because this next slide shows us the distance formula. I'll actually even leave that up right there. Distance, it's a length, right? So say we're given a segment AB, and we want to know the length of this. Just like we would want to know the length of C, it's this formula right here. It's the square root of the difference in x's squared plus the difference in y's squared. So it's very, very similar to this. And I could go into more detail, but I think this is probably good enough. Write this down. You are going to need it. So take a minute and do that. All right. So let's look at a problem then. What is the distance between 13.2 and 7.10? All right, well, let's call this x1 and y1. We can call this x2 and y2. And remember that my distance, I can just say d if I want. In this case, though, I actually do have AB, equals the square root, and I like to do this. It kind of looks like a person, 2 eyes and eyelashes, and anyway. And I'm taking my x values and I'm subtracting them. So 13 minus 7. And now my y values, 2 minus 10. And unlike the slope, in this one it doesn't matter because you're going to square them and they're going to be positive anyway. So I have then 13 minus 7 is 6. I'm going to square that. Plus 2 minus 10 is 8, and that's squared. So that's the square root of 36 plus 64, which is the square root of 100, which is 10. So if I were to look at this on a coordinate plane, and I were to measure it, I would get 10. Okay, so here is a real life example. And living in Provo, we have the grid system. That's our address. Somebody asked me what street I lived on the other day, and I'm like, they were expecting like Main Street or something. I'm like, 390 East. And that was kind of weird to them. But anyway, we're going to plot these points from this problem on here. All right, so your school is 4 miles east. So north, south, east, west. So we're going to go 4 miles east, 1, 2, 3, 4, and 1 mile south. So that is 4, -1. A recycling center where your class is going on a field trip is 2 miles east, okay, and 3 miles north. 1, 2, 3. So this is 2 and 3. And we want to estimate the distance between the recycling center and your school. Now, this would be like if your drone was flying, right? Because you could go in a straight shot. Or if it was across from a really big field, because typically we don't go in a straight line. All right, so let's look at this. My distance then would be my x values, 2 minus 4 squared, and 3 minus a -1. So 3 minus a -1. So I've got here -2 squared. Remember that the whole thing goes in parentheses. If you don't use parentheses, it'll make it negative, but it's -2 times -2, which is going to give me a +4. Plus 3 plus 1 is 4 squared. So this is 2 times 2 is 4. 4 times 4 is 16. So I'm looking at the square root of 20, which is about 4.5, I think. Yep, about 4.5 miles. I had an example that I wanted you to try on this, but I changed my mind. Okay, I gotta turn this off quick or this video is gonna be too long. Look for your homework. This is all I've got. Look for your homework and we will see you next time.